All right. Important announcement first. All right. Important announcement. Last Wednesday, I released the preparation guide and practice question for lab test 2. Hopefully, you started looking at that. Okay. So lab test 2 is going to occur from next Monday. Okay. For this week, we're still doing the regular schedule. Okay. And we have covered many examples in the tutorial videos for this week, especially how you can distinguish between computing for all the numbers are positive versus at least one number is positive. So that's something I cover in detail in the tutorial videos. And also how we can determine if the array is sorted. So these are the two kinds of problems we solve in the tutorial videos. I just want to give you a very quick summary, like what you have to pay attention to. And then I'll move on to something that's more interesting. Okay? Okay, guys, can we start? All right. Okay, a very quick reminder. Whenever you're given a problem which is going to tell either true or false, it's a Boolean type. For example, if you want to know if all the members or the elements in the array satisfy a certain property, a property can be if all the numbers are even number, or all the numbers are multiples of 7, or all the numbers are positive. So these are the same kind of problem. Okay? So there are 4 versions we have to know whether each one of them either works or doesn't work. So that's something I cover in detail in the tutorial video. Okay? I'll just highlight the important stuff to you very quickly. For version number 1, we simply scan through the array entirely as usual, and then we simply reassign the Boolean variable we are trying to accumulate, and the way we accumulate is using %. Okay? This is for this particular kind of problem. What if I say, let me just change the problem a little bit. The problem rather is there at least one positive number? So this is the second kind of problem that we're trying to solve in the tutorial video. In this case, everything remains the same, except that you have to use disjunction rather than conjunction. Okay? That's how you accumulate. That's version number 1, which works. What about version number 2? Version number 2 is the only version that does not work. So we still have to initialize the counter to be 0, and then we go all the way to the end. However, you can see in the body of the loop, we simply reassign the Boolean variable to whether or not the current elements satisfy the property. And we argue that in the tutorial video in detail. This actually doesn't work. Okay? A very quick a very quick reminder about why this wouldn't work. Because in the body of the loop, we are simply going to reassign whatever value it is for the current elements into the Boolean variable. So that means always you only get a result from the last element in the array. Okay, that's something I assume you already watched the video and you kind of get it. If you don't get it, please speak to me. Okay. Number 3, version number 3 and version number 4. The crucial point to look at is we are trying to make the state condition more sophisticated over here, right? The state condition. We simply say that usually, not only that I must be strictly less than the size of the array. That's the normal stuff. We also say, but also it must be true at the same time. We have not found any violation so far. Okay, that's something also we discussed. And as soon as you find any number that is not positive, you're going to make the state condition over here false, and then exit from the loop immediately. Okay, that's something we talk about. And then you can see either we can use accumulation or we can choose not to use accumulation. So version number 4 over here is the most concise version you can write. Okay, again, you should really try to see what's the difference between each of the 4 versions and try to understand why they work and why they don't work. Okay, that's something I want to remind you quickly. Okay, so now let's go on to the new topic. Okay. One more thing to mention. So when you go over the slides, everything has been covered in the tutorial video. So that's why I don't want to repeat to bore you. So if you look at this particular slide, it's cut off over here, but it's called observations. So now, whenever you want to solve any problem using an array, for example, in your lab test, I would say typically you have to scan through the entire array from the beginning until the end. Okay, that's something we have done for many examples. For example, if you want to find out the maximum, the minimum, the total, and etc. One of the practice questions you have for lab test 2 is about how to find the second maximum in the array. So that's quite an interesting problem to solve for you. Okay? Again, in the lab test, you are not allowed to use any library classes in Java, which means everything has to be done from scratch by you. Okay? So something I want to mention very quickly. All right. And then, if you're asking, you're being asked the kind of problem where you want to find out if all the elements in the array satisfy a particular property, what you can do is you can try to say, I will exit from the loop as soon as I find out something that does not satisfy the property, in which case I know it's got to be false. Okay? That's kind of, for the rationale, again, I'll refer you to the tutorial videos. Okay? Hopefully you're okay with that. Let me talk about some very small topic before I move to some very, the meat for today, which is nested loop. I'll get there in just a moment. Okay, let's now, we learned about short circuit, right, before the reading week. Think about what short circuit is. It might be difficult to recall, but that's something you have to know. Okay, so this is the second time we talk about short circuit. Let me just remind you very quickly. Basically, whenever you see short circuit, think about logically. Okay, let me just put it here. Short circuit, basically short circuit evaluation. Okay, that's something that was covered in your previous quiz. Let me remind you very quickly, and then we're going to apply that again. We have these two binary logical operators. Let's say you got P, which is a Boolean variable. You also got Q. In the case of conjunction, we know that it will only be true if both of them are true. In the runtime, the evaluation is going to go from left to right. If I know already that P is already false, I don't have to bother to evaluate the right-hand side because overall it's going to be false anyway. Okay, that's the short circuit effects for conjunction, which we covered already. Okay, what about disjunction over here? So this is disjunction. If you got P or Q over here, okay, it's kind of symmetrical. We know that disjunction will only be false if both P and Q are false. We'll put it another way. The disjunction will be true as long as either P is true or Q is true, either one of them. It doesn't have to be both. So that means if I know already from left to right evaluation at the runtime, if I know already P is true, do I need to bother to evaluate Q? No, I don't have to. Okay, it's a very quick reminder. Now we have a very useful application for short circuit when you want to write loops and array. Let me show it to you. Okay, it's another application to strengthen your understanding. Okay, let me show you what the problem is first of all. And it's actually very nice aligned to the problem you're trying to solve in the lab. Okay, let's have a quick look. Okay, basically, let me read the problem to you. Sorry, again, it's being cut off. We want to ask the user how many integers they would like to input, and then prompt them accordingly. Let's say if they want to enter 3 integers, we're going to prompt them 3 times. And then we want to determine, overall, we want to go to a particular position of the array under the hood, and want to know if that particular number stored in that position is even number or not. I'll give you one example right away. Okay, you can see, first of all, we ask the user, how many integers do you want to enter? If they say 2, that means we want to prompt them twice accordingly. Prompt them the first time, they enter 23. Prompt them the second time, they enter 24. And then we can give them any arbitrary index over here as an integer. It can be 0, it can be 1, which are valid because they're 2 integers. Or it can be -1, it can be also 2, which are invalid. Which means from the user's point of view, we don't constrain them on what integers they might enter. From our point of view as a programmer, we want to do some error handling. Okay, so that's something I want to show you. In this case, we are lucky, the user, they're pretty kind. They simply say 1, index 1, which will be the second integer, which will be 24. And 24 at index 1 is even. Okay, this is a very simple problem you're trying to solve. Let me present to you a particular solution. Let's criticize on that, and let's see how we can fix it. And the solution for the fix will be short circuit evaluation. Okay, let's see. Okay, let me go there. Let's have a look at that all together. You know what? Let me just present the code to you. Okay, that will be good. Okay, your code will go something like this, which we are pretty much familiar already. Let me just go over. Line number 1, we simply declare the scanner. Line number 2, we simply prompt the user how many integers would you like to enter. Line number 3, whatever integer user enter, we're going to prompt it this many times. Okay, that's going to be how many. And then line number 4, we're going to create an array of that particular size. If they say, I want to enter 4 integers, create an array of size 4. Okay? Now, the next step. Since we know how many integers the user wants to enter, we can simply write a loop, right? Let's go from 0 until how many, right? Just that many iterations to be run. And then every time we're going to say enter an integer. And whenever the user enters an integer, we can simply store them into that particular position. I think that's something we covered also in a previous tutorial video. That's just a simple application. Okay, and then we simply, so this here comes the critical part. Once the user enters all the numbers they want, they can simply ask, given an index, and then they can enter any integer. You can see simply integer I is assigned the input and next int, which can be any integer. It can be from 0 until the array length -1, or can be outside the range, can be anything. Now, let's look at line number 10 over here. We say that whatever I, the user, enter, we're going to say ns at a particular position modulo 2 equals 0, which means that number is even. If it is even, we'll tell you that it's even. Otherwise, we might give some error to tell them, well, it's not even, right? Okay, that's kind of the code structure for you. So the same code structure over here. Let's have a quick look. What's wrong with line number 10? Everything compiles, but you might run into some exception or error at the runtime, right? Hopefully you can see what's wrong here, right? Okay, let's just go over it. Well, I also gave you some hints by giving you some test case. Let's do that quickly. One example would be, because the user, when we say enter an index to the user has no constraint whatsoever what they want to type on the keyboard. Let's say case number 1. If they simply type -1, that means I is going to be -1, and then I will be -1 over here. In that case, let's say previously, they simply say they're going to enter 3 integer, let's say. So that means the array is of size 3, like that. But now, when they enter -1, it's simply just going to be invalid, right? There's no -1. Similarly, if the user, let's say case number 2, if they actually enter 3 over here, let's say they enter 3, that case, I will be 3. Well, 3 is also not a valid index here, right? You can see both cases, your program is going to crash, which is bad, all right? Now, we want to see from your point of view how you can actually fix this program over here, okay? Basically, you want to check to see if the indices are valid before you try to use them, okay? Again, this particular slide, I'm showing you one version of the program, which is very easy, but it's wrong, okay? I would like to make some slight extension using short circuit evaluation, which I just reviewed, and then you can fix the program quite nicely, okay? That's why I want to talk about this example. And I'm going to show you 2 versions of fix. Version number 1, I'm going to use the conjunction as the fix. So now when I move on this wrong version to the correct version, the only thing I changed was this guy here. Let's look at line number 10 again, okay? If you look at line number 10, you can see that we used to get ns at position I modulo 2 equals 0. That's what we used to have. But now I put some conditions beforehand. What did I put? I say that I must be greater than or equal to 0, and I must be strictly less than ns.length. That's exactly the constraint for I to be valid index, right? Okay. How is this going to work at the runtime? Again, short circuit evaluation is very intuitive. You try to evaluate these conjunctions from left to right. I will evaluate this condition over here at the runtime first. If it is true, I will bother to go on. If it is false, stop right away. Don't go on. If it is true, I'm going to evaluate the second one. If the second one is false, I'll stop there. Okay? If the first one and the second one are both true, that means I can be safe. I can safely use the I over here as an index. Okay? That's the intuition. Let's try to trace the code very quickly. Again, let's use the 3 test cases. Okay, test case number 1. Let's say -1. You can see apparently -1 is an invalid index for this array of size 3. If the user simply give -1 over here, what's going to happen? So that means we're evaluating the following. We're evaluating -1 less than, oh, sorry, let me say it again. So we're evaluating this condition first from left to right. 0 less than or equal to -1. This is false immediately, which means we are going to stop right here. We don't even go on to do anything further. We stop. And that means we're going to bypass and go to else, and then do some error handling. So why is this better? Remember in the previous case, if we simply say -1 over here and then use -1 directly as an index, we're going to crash with the array index out of bound exception. But now, with this particular condition, which I call as a guard, if it is false, I'm simply going to stop right there. I don't even give you a chance to actually use that value for index. Okay? Let's do one more. What about test case number 2 over here? Okay, test case number 2 over here is 3, which is too large, right? 3 is actually too large over here. So let's try to see. So the user enters 3 over here, and then I'm going to evaluate basically this condition, the leftmost first. 0 less than or equal to 3 is going to give me true. That tells me I should go on. Okay? And then I'm going to evaluate the middle one over here. That's going to be 3 less than ns. The length for this particular array is simply 3. What's that? Well, false. Right? 3 less than 3 is going to give you false, which means I'm going to stop right there. I don't even give you a chance to go further to the third expression there, right? You can see the use of short circuit is very useful over here. Okay? I do have some exercise for you to think about, but let me just show you another variant, another version. So over here, we're fixing it using the short circuit for a conjunction. How do we rewrite the same idea using disjunction, using short circuit? Okay? The idea would be, the way you specify the conditions over here, they are valid conditions. Which means this is valid and this is valid so that I can go on to evaluate this. In the case of the disjunction, we're going to go the opposite way. Okay, let me show you. Okay, that's the second version of the fix. Again, you can see the only place I fixed was line number 10. Okay, over here. Let's have a look at this. I have 2 conditions over here. Okay, and this part is still the same. We're using I. It's put in the rightmost position, which means the previous left left expression must be evaluated before I can go on to the third one. And I'm using disjunction over here. Okay, that's something I want you to pay attention to. So now let me go a little bit further. I want you to compare these 2 conditions: I strictly less than 0 and I larger than or equal to ns length. In the previous version, I said those 2 conditions are valid conditions. What about these? They are invalid conditions, which means if you satisfy these 2 conditions, that simply means your index is simply not valid. Okay, I'll put it down here. Invalid conditions. Intuitively, if any one of them happens to be true, you do not bother to evaluate further. Intuitively. Okay, let's just do a test case very quickly. And of course, you really want to think about how you do one version and also the other, right? In the quiz, maybe later, or in the exam, I might try to maybe swap around the operators to trick you a little bit. So you want to make sure you understand that pretty well, okay? So now let's trace them very quickly. Let's say the first one, let's say simply -1, right? For -1, we're going to evaluate the leftmost one first. So -1 less than 0 is going to be true. True means it is invalid. And once we get true for the disjunction, we stop right away because overall it's going to be true anyway, right? And then we're simply just going to do some error handling over here, okay? What about the second case? In the second case, we have 3 over here, which is too large. What about that? Again, we're going to evaluate the leftmost one over here. 3 less than 0 is going to give me false, which means 3 is not invalid in this particular perspective. And then I'm going to evaluate the middle one. For the middle one, it's going to be I, which is 3, larger than or equal to ns length 1, 2, and 3, which is going to be true. That means even though I don't satisfy the first invalid condition, I do satisfy the second one. So it's true. So that means I'm gonna stop over here. I don't move any further. Okay? Any questions quickly? Okay, so if you were previously a little bit confused with why short circuit evaluation is useful, this is another response to your question. So I would say this might be one of the most common usages for the short circuit evaluation, very practical. So you always want to make sure whenever you use an integer as an index into your array, always check it. Okay, always make sure it's neither too large nor too small. So you don't run into the array index out of bound exception. Okay, questions? Okay, that's good. So now what I would like to do is give you a quick question. So now, this is an exercise I want you to think about. I do have more exercises on the slide. You can also try to complete it in a similar way. Let's just do one, that'll be enough. So now, this is line number 10, let's focus on that. This is the working version. I got valid condition number 1, valid condition number 1, and valid condition number 2, right? That's what we just went through. Now, I want to do some little change over here. You can think it this way. Think about this condition here is P. This condition over here is Q. And this condition here is R. Now, I want to swap the order of P, Q, and R, right? In the version I showed you previously is P and Q and R. Now I want to do it differently. I want to do, first of all, P, and then I want to do R, and then I want to do Q. You can see what I'm trying to do here, right? It seems like nothing fundamental has been changed because it's the same 3 Boolean conditions. I just swapped their order. Do you think it's going to make a difference at the runtime? How exactly? Right? Think about it. Or let me make it more precise to you. If in the previous version, I simply tried test case number 1 and I tried test case number 2. Both of them do not result in any array index out of bound exception. What about this particular version over here, where I swap the order of the Boolean conditions? Which one is going to fail? Test case 1 or test case 2? 1 or 2 is going to fail. Can you see? Or should we derive the answer together? Let's try, okay? So now, we basically have, let's say test case number 1, okay? Now, I is basically -1, so let's put -1 over here. -1 larger than or equal to 0 is immediately false. So that means false is going to make sure we don't go any further. So test case 1 still seems to be okay. So we still have that guarding condition over there. What about test case number 2? Okay? If you think about test case number 2 over here, it's 3. So that means I over here is going to be 3. 0 less than or equal to 3 is going to give you true, right? That means from that particular perspective, 3 is valid. However, and then we're going to go on to do the next one, right? Because it's true. However, before we get a chance to evaluate this particular condition, we will use it as the index first, right? Always remember the evaluation is from left to right. You got to follow this particular order. Because this particular check is too late. So that means when we try to use 3 over here as the index, you're going to get array index out of bounds exception. That's what you will get. Okay? Are we okay with this? Okay, let me just recap very quickly because I do have many more similar exercises for you on the slide. You can go through them for your understanding. What I'm trying to do here is short circuit evaluation depends on the order of the expressions. So you should always put all the guarding conditions at front before the very last one on the rightmost position to actually use it. Okay? And this is just one example where I wasn't careful enough. Okay, so do get prepared. If I give you a particular arrangement of the conditions, you want to judge to see whether, number 1, whether that will work or not. And number 2, under what circumstances particularly is it going to fail. In this particular case, we know that it's going to fail when the index is too large. Okay? Questions? We okay? Good. Once we're done with this, okay, let's talk about something fun. Nested loop, which will be very useful. Okay, that's about what I just went through. Let me just go directly to nested loop very quickly. Okay, we're done with this. Okay, this is the slide I'm talking about. If you go to this particular slide, it's called the indexing and short circuit logic, number 4. Okay, and for that one there, we just went through one of the examples there together. So you can just went through the rest. They're done in a similar way. But again, the order of the conditions matters. Okay, so I'll let you go through it. If you've got trouble, let me know. Okay, and also you want to do some exercise where the operator over here is disjunction as opposed to conjunction. Okay, I'll leave the exercise to you. Okay, so now let's talk about a particular kind of loops. So far, what we have got for the loops, they are in some way they are parallel, which means they're independent of each other. For example, I might do one loop over here, followed by just another loop, right? They're kind of doing independent jobs. But now, sometimes you might need a particular kind of structure where the body of the loop is just another loop. That's so-called nested loop. I want to give you the simplest example to give you some intuition about especially how the loop counters will change in the nested loop. And then we'll do one example together. Okay? Again, I'm going to show you different versions. Okay, so now let's have for the nested loop. I want to talk about this particular example. I will go through in details. One thing I want you to keep in mind: nested loop. The reason that it's complicated is you're basically trying to figure out. Let's say if I got two loop counters. Let's say one counter is from 1 to 10, another counter is from 1 to 10. The reason that it's complicated is because you're going to end up having, rather than 10 plus 10 iterations, you will get 10 times 10, 100 iterations. Basically, you're trying to figure out all the combinations of the loop counters. It's just something I mentioned verbally. Okay, so now let's have a look at the code together, right? First of all, let's try to read it together, okay? Basically, what I have is I have a loop over here, loop counter I, and then the standard way of going through the array one by one. And then, as the body of this particular loop, I have another loop over here. Think about what we're trying to do here. Okay, let me show you again. You can think about this is the first for loop over here, and we have inside this particular loop just another for loop. Okay, that's so-called nested loop. Of course, in practice or in theory, you can nest for as many levels as you like, but I think 2 should be enough for this course. Okay, so the way I'm going to explain to you is I want to, first of all, let's show how you can use a flowchart to actually understand the behavior, and then we're going to trace the program all together. Okay, overall, you're going to see that exactly what's going to be output to the console over here will be all the combinations of I and J. Eventually, that's what we'll see. But let's first of all understand how we can translate this program over here into flowchart. Let's do that quickly first, and then we'll do the next slide, some tracing. Okay, this is what I would like to do. Okay, let me just erase these markers over here. Okay, so now let me use blue over here for the outer loop. So we do have some initialization over here. This is the initialization I have. Start with I is assigned to 0 for just once and for all, just once. And then I do have some state condition over here, and then that's a state condition over here, which can be either true or false. In the case where it is true, I'm going to try to execute the body of the loop, which is just another nested loop, right? In the case where it is false, I'm just going to exit from the loop and then do something else, right? Let's understand the big structure first. In the case where the state condition is actually true, that means I want to repeat the body of the loop for another time. How's that going to work? Let me show you in pink. So this particular inner loop, first of all, we also have a single initialization for the loop counter. It's exactly this guy here, right? You're going to initialize J to be 0. And then we're going to check to see whether we should stay in this particular inner loop. If we do stay, and we check this particular condition over here. Okay, we check it. J less than 8 length. If it is false, okay, let me just say the case of true. If it is true, that means we're going to execute the body of this inner loop. So what does that mean? That means we're going to execute the body of this particular loop, which is just the print statements. That means we're going to execute here. Okay? And because that's the only line of the loop, after that, at the end of the inner loop, what should we do? we should increment the loop counter, remember, right? Always remember to increment the loop counter. So that means we're going to go into this particular line over here to increment, and we'll do j++. Again, and then after that, we're going to go back to the state condition here for the inner loop and to see we should go for another iteration. Now, the most tricky bit, what if the state condition for the inner loop over here happens to be false? If it is false, that means we are done with this particular inner loop, then that means we should go to the end of the iteration for the outer loop. So that's the trickiest bit I want you to understand. If it is actually false, that means we're going to go to the end of the outer loop for this particular iteration, which we'll do I++. Okay? So at the end of that, we're going to say I++ over here. And after that, we're going to go back to the state condition over here and then try to evaluate it again, either true or false. Why don't you stare at this flowchart just for a little while? I'm going to move to a clean page in the next slides. The purpose for this slide is just to see, first of all, to see the syntax for the nested loop, and then how you can translate it into the flowchart. You don't really have to draw the flowchart when you do the problem yourself, but for the very first time, it's better to understand this using a flowchart. Okay? Hopefully the colors also help. Any question about this flowchart over here before I move on to trace? Okay. Okay. So the next slides, I'm going to use the same block of code, the same flowchart. Let's see exactly how things work, iteration by iteration. Okay. Let's see. Okay. There's this slide here, the same block of code over here. So now let's assume the array that we talk about over here is simply just A. Okay? And then, as I said before, verbally, every time when you have nested loop, intuitively, you're basically trying to figure out all the combinations of the loop counter values. Okay? So now, let's anticipate what's going to happen quickly. The loop counter I over here is going to be from 0 until 2. And also the loop counter J is also going to be 0 until 2. So I can be, I can be 0, 1, and 2. J can also be 0, 1, and 2. Eventually, we're going to have 9 iterations to consider all the combination of I and J, eventually. Okay? Or let me just tell you what the output is going to look like very quickly, and then we'll trace it. Eventually, we're going to have, because every time we simply print out I followed by J. Okay? Eventually, it's going to be 0, 0, 0, 1, 0, 2. And then 1, 0, 1, 1, 1, 2. And followed by 2, 0, 2, 1, and 2, 2. Exactly 9 outputs, 9 lines to the console. Okay? Let's see exactly how this is going to happen. Okay? We're going to trace 9 different iterations. But I think that once I go through the beginning few, you should see it. Okay? Let me just clean it quickly. And then we're going to go through that together. Okay, so now let's see this. Let's see for the outer loop, I'm going to use blue over here, the blue. We first do the initialization over here. I is simply assigned to 0. So that means I is beginning to be 0. And then I less than a.length. A.length, we know that in this case is simply just 1, 2, and 3. So it's going to be 3. Okay, let me put it down here. Okay, so now 0 less than 3 is going to be true, right? So that means we're going to go into this particular inner loop over here. Okay, so what have we done? Basically, what we have done is we execute this particular initialization, and then we evaluate this for the first time. And the first time we simply got 0 less than 3, and it's simply just going to be true. In that case, we're going to evaluate the body of the loop, which is another loop, the pink one. Okay. Now for the pink one, we're just going to initialize another loop counter called J, and then we're going to check the state condition for the inner loop. Okay. Let's see exactly how that's going to work. First of all, I'm going to have initialization over here. J is going to be 0, right? J is simply just going to be 0 over here. And then I'm trying to evaluate this particular state condition here for the first time. Okay? So what do I have? So basically we got 0 less than A.length, we know that is still going to be 3, the same array. 0 less than 3 is going to be true. So that means I'm going to execute the body of the loop for the first time. So now let's see the green. Okay, so now what should be the output from here? Well, 0 followed by 0, right? What's the value for I? 0. And what's the value for j? Also 0. So from this, I'm simply just going to get, let me just say the output over here, the console output. The very first one I will get is simply 0 followed by 0. So what happens after this? That's at the end of the very first iteration of the inner loop. That means I have to increment the counter of the loop. Okay, let me increment the counter of the loop over here, and then let's see what happened. So now I'm going to execute j++. Let me use this. I'm going to execute j++. So that means j is, you can see I stays unchanged. Only j is incremented. So when j is incremented, it's going to go from 0 to 1. Okay? So now, when I try to evaluate this particular state condition here, right, you can see after incrementing, I'm going to go back to check the state condition again, right, as usual. What do I evaluate? I'm going to evaluate 1 less than 3, which is going to be true. So that means I'm going to evaluate this print statement again. Okay? So what's that going to be? Well, that's going to be exactly 0 and 1, right? Because I hasn't changed so far. So what I will get is, I will get 0 and then 1. Okay, so far so good? The next iteration will be done in a very similar way. Let me just put it down quickly. And then, well, I'm going to talk about how we can get out of the inner loop. The next one is also going to be 0 and 2. Okay? Because when we try to evaluate, when the counter value for for j over here is simply just 2. 2 less than 3 will still be true, right? We know that that's the third iteration for the inner loop. At the end of the third iteration, we're going to, so I'll put 2 here. So that means at the end of the third iteration, we're going to increment j further from 2 to 3, okay? However, we know very well, in that case, when we try to evaluate this state condition for the fourth time, when you have 3 less than 3, it's simply just going to be false. So we don't go for the fourth time. We don't. Okay? So this is not going to be considered. Okay? That's why we only got 0, 0, 0, 1, and 0, 2. Okay? Now, as soon as, this is the most critical part to highlight. As soon as we get this particular fourth check on the state condition, it's going to give us false. That means we're going to go to the end of the outer loop, which means we have to increment the counter value for I, right? If you want to increment the counter value for I, it's going to be incremented from 0 to 1, okay? And then once it's been incremented from 0 to 1, we're just going to go back here to check the state condition again. And now what do we check? Because now the I value becomes 1. That means we're going to check to see 1 less than 3. In this case, it's just going to be true, right? So what we have just done, for a single iteration for the outer loop, for each single iteration for the outer loop, it takes 3 iterations for the inner loop to actually execute, right? That's exactly what we have seen. So you can see, let me just say this. This is a single iteration of the outer loop. On the other hand, you can see over here, these 3 are 3 iteration of the inner loop. Okay, that's kind of the pattern we're going to follow. How many iterations do we have for the outer loop? Because we know I is going to be 0 until I is equal to 3. So we know that we got another 3 to go. And for each one of them, we simply got 3 each for the inner loop. So that's why in total we got 9 iterations, right? Let me just write down the complete output here. Eventually, what you will get, let me just make this a little bit more straightforward to you. Okay? Okay, let me put it here. Let me just say that again. Eventually, let's see this. So this is the first iteration of the outer loop. Okay, and then followed by that, we're simply just going to get the second iteration, which is going to be it's going to be 1, 0, 1, 1, and 1, 2. And this is going to be the second iteration. Okay, that's the second. Okay, followed by that, we got basically 2, 0, 2, 1, and 2, 2. So that's the third iteration. Okay, you can see for each one of them, you simply got 3 iterations for the inner loop. That's why in total we got 9 lines of output. Okay, are we okay with this? Okay, that's kind of the simplest example you can see for nested loop. Hopefully you can see. I want to say you want to pay attention to exactly how the values for I and j actually change over the iterations. That's the most critical point to pay attention to. Okay, so now I want to do one small case study with you. How can this be useful? A very common problem to solve would be, let's say given an array, we want to see if the array contains any duplicates. Okay, let me show you the problem first, and then we'll see how we can use this to solve it. Okay, so now let's read the problem together. I'll read it to you. Given an integer array A, determine if it contains any duplicates. For example, you can see if the array looks like 1, 2, 3, 4, all the elements are unique. There's no duplicates, so the answer should be false. And on the other hand, 1, 4, 2, 4, we do have a duplicate of 4 because 4 appears more than once in the array. In that case, that should be true. Okay? So this is what we have to solve. Without using a nested loop, it's just not possible to solve it. Okay? Basically, let me give you a very quick intuition. Remember, the reason I talk about nested loop is because we have a way to actually consider all the combinations of the 2 loop counters, I and j. They're independent, right? So now, let's say we're given an array that looks like this. Let's say, I could make it even easier over here. Let's say index 0, index 1, index 2. Okay? Let's say it looks like 4, 2, and 4. Okay? So now, do we have a duplicate for this one here? Yes, we do, right? You can see specifically it's for index, let's say this is A, array A. True, simply because A0, which is over here, is the same as A2. Because these 2 slots, which are different slots, they have the same value. So that means we got duplicates, right? So that'd be true. So what's the intuition to this? Given that nested loop can help us consider all the combinations of the loop counters, we can consider basically every pair of the indices in the array. We want to see if there exists just one pair of indices, they actually contain the same elements. If that's the case, that means we're done. There's duplicates. Otherwise, if there's no such pair, there's no duplicates. Okay, that's kind of the logic. Let's have a quick look. For this particular case, what we want to consider would be something like this. We want to see 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and also 2, 0, 2, 1, and 2, 2. So these are the 9 combinations we just talked about. Okay? I want to draw your attention to this. First of all, you can see that as soon as we actually reach over here, because we know that A0 is equal to A2. Okay, so that means we do have duplicates. Okay. Now, one thing to ask you about. If you simply try to check to see this particular pair, A0 equals A0. No doubts about it. It should be true, trivially, right? But now, having true over here, does that imply we have duplicates? No, it doesn't, right? Because you shouldn't really compare the same position twice. So when you talk about every pair of the positions in the array, you talk about distinct positions. So you want to make sure somehow in your loop, you want to make sure, number one, I'm comparing 2 different positions in the array. And number 2, if these 2 positions which are distinct contain the same value, there's a duplicates. Okay? So these are the 2 points you want to pay attention to. Let me show you the solution right now. Okay? If you look at the slides, you will see the code and also you will see the tracing. I will just highlight something you have to pay attention to. Okay? Again, I actually got 3 different versions. All of them work in the slides. I only plan to go over 2 versions with you. I will just do at least one, and then we can finish the rest in the beginning on Wednesday, and then we're going to move on to other topics. Okay? So now, let's say line number 2 is simply set up an array. Let's say 1, 2, and 3. As you can see, there will be no duplicates, right? And then we simply have has duplicates is a Boolean variable. We want to make sure every pair in the array, we want to make sure they store different elements. Otherwise, we have duplicates, right? Okay, that's basically like an OR problem we're trying to solve. So now let me again we can see we got a nested loop. That's the outer loop. We got I, and also we have the inner loop where we got j. Okay, outer loop and inner loop over here. So now let's have a look at the body of the loop. That's the interesting bit. Line number 6. Okay, let's see what we are trying to do over here. We want to say basically we're trying to do some accumulation over here using disjunction. We want to say as soon as we find out any pair of indices such that, first of all, the 2 indices are different, which means I shouldn't really compare the same index twice. I should always compare distinct positions in the array. Okay? As soon as I find out, first of all, the positions are different, and also the elements they store in these 2 distinct positions are the same. If both conditions are the case, that means I have a duplicate. So this is the conditions of duplicates. Okay? And now, since we have a nested loop, what does that mean? Since we have a nested loop, you can see we got 0, 0, 0, 1, 0, 2, and also when I is equal to 1, we got 0, 1, and 2. When I is equal to 2, we got 0, 1, and 2, right? That's kind of the pattern we just talked about in the flow chart. Okay? I want to highlight some interesting bits to you. Okay? So now for every combination of the index over here, I want to, number 1, let's have a look at when I and j are actually the same. As we said before, you should only consider distinct positions. You shouldn't really consider the positions when they are the same. Okay? So that means I is not equal to j. You got 0 not equal to 0. That will simply just give you false over here, right? And that means you're going to get false immediately for this. And short circuit tells us this particular condition here is simply just be false. So we don't consider that anymore. Okay? One more thing. And then you want to see something here. When we actually get to 0, 2, which means we're considering this element and this element over here, right? There's no duplicates, right? Just another condition. One thing to note, when you get 0, 2, and also 2, 0, so these 2 rows over here, this row here and this row here, you can see there's kind of like a redundancy over here, right? Since we already checked 1 is not equal to 3, why should we bother to check 3 is not equal to 1 again? So there's some redundancy here, even though it works. Okay? I will stop here, and then I will continue with this on Wednesday. Have a look at the code for the 2 versions before Wednesday. That will speed up the discussion. Okay?